Welcome back. In previous lectures, we learned that sometimes definite integrals are not easy to be evaluated, but by means of the double integral, we can integrate it, means we can evaluate the integral. But sometimes again it happens that the evaluation of the double integral cannot be done as it appears. Then we try to change the order of integration, and by means of order of integrations sometimes we evaluate the integral. So in this lecture we will learn how to change the order of integration. First we will learn the method, then we will learn through some questions, some examples, how to change the order of integration, and then finally we will see some integrals which are not directly integrable, and after changing the order of integration we can easily integrate them. So let us start with the method and then with the example. First, what is the change of the order of integration? So you can see an integral here, the double integral, outer limit a to b, this is limit of x, and then inner limit f1x to f2x, this is limit of y, the function is phi xy. So this is the double integral. What is the change of order? Change of order does not mean directly you write dy by dx as dx by dy. It has some certain aspects. So first point is y has the variable integral. Variable integral means limits of y are variable. Limits of y are f1x and f2x. These are function of x. So as the integral appears, we will integrate first with respect to y, and after the evaluation of y is completed we will have the function of x only in the integrand, then we will integrate this with respect to x. So you saw that there is an order, first we integrate with respect to y and then with respect to x, means first integrate with respect to the variable which has variable limits, then with respect to the variable which has constant limits. So this is the order. When we try to change the order, it does not mean directly that you write dy dx as dx dy dx as dx dy, and you say that order has been changed. It does not mean. Then you will integrate with respect to x first. X will be after integration it will be replaced by the constants a and b. Then after integration with respect to y, we will end up with a function of x, not we end up with the value of y. So this is not the meaning of change of order of integration. Then what is change of order? We have to go through certain process. And what is the process? So we need to readjustment the limits. Once we readjust the limits, what are the readjustment? We will take the variable limit for x and the constant limits for y. Then we will change first with, then we will evaluate first with respect to x and then with respect to y. So this is the change of order. But how do we do that? So let us go through the detailed process. Suppose this is our integral, double integral, outer limit is a to b and inner limit is f1 to f2, phi xy is the function. So first thing that we need to do is write the limits. So we identify that limits of x are a and b. So x has limit a, y has limit b. So we write down it. Then identify that y has limits f1 and f2. So write down the limits of y. Y is equal to f1 and y is equal to f2. Now with help of these limits we have certain information. So as a step 2, first be sure and be informed, this will not vary, that region of integration is bounded between x is equal to a and x is equal to b. What is x is equal to a and x is equal to b? These are vertical lines at x is equal to a and x is equal to b. Vertical lines means lines parallel to y-axis. So first draw these lines parallel to y-axis. So the whole region of integration is bounded between these lines. Second, the region of integration is also bounded between these curve y is equal to f1 and y is equal to f2. So how do we find these? So first find the point of intersection of f1 and f2. This will give you an idea where is the region lie, where is the region lying between A and B. So suppose we have found the intersection of these curve, and sometimes we also need to find the intersection of these curve with x is equal to A and x is equal to B. So we observed all these data and plotted the graph. Suppose this is our graph. This is the point A0, this is the point B0. So you can draw straight lines as there are already appearing in the figure. So then you can draw the graphs y is equal to f1x, y is equal to fx, f2x. How will you decide? Actually, you do not need to perform the curve tracing to decide which curve is below and which curve is above in the bounded region. There is a shortcut directly you can decide this. So the curve, the function in the upper limit form the upper curve in the boundary region. So y is equal to f1x, y is equal to f2x is upper limit. So y is equal to f2 will be higher in the bounded region. Means this will lie above, and y is equal to f1x is lower limit. So this will lie below in the bounded region. So this is why I have written this curve as f1x and this curve as f2x, because f2x is upper curve in the bounded region. You can see outside the bounded region the information is not correct. Outside the bounded in this region f1 is below and f2 is above, but in the bounded region f1, f2 is above and f1 is below. So this is one information that facilitate us to draw without performing the tracing of the curves. So after you have identified the bounded region of integration, decide the new limits. Limit of y will be taken constant, and how will we take it? So lower limit of y is minimum height of the region. Suppose this is the curve, we have already drawn this. Suppose this is the curve. So if this is the bounded region of integration, then the minimum height is at this point. Minimum height of the region, below this point there is no region that we are interested to integrate on. So we have to take the minimum height as the lower limit of y. Then take the maximum height of the bounded region, this as upper limit of y. So these are lower and upper limits of y. So we have obtained the limit of y. So y lies between c and d as per our plot. Now how will you take the limits for x? So just draw a horizontal strip. You can see here is an strip, and start moving from left to right. When you start moving from the left to right, the first curve you meet with gives the lower limit for x. So this curve has equation y is equal to f2x. So y is equal to f2x. You meet this curve first. So x can be written as f2 inverse y. So x, this is the lower limit of x. So this is the lower limit of x. Then final curve means second curve that you meet in the last. So that that lies on the right side. So this is right curve y is equal to f1x. So this will give you x is equal to f1 inverse y. So this is the upper limit of x. So we obtain the upper limit of x. So now we obtain lower and upper limits of x and y, and just put these limits. So outer integral means constant limits are for y. So y has limits c to d, and x has limits f2 inverse y, f1 inverse y. lower to upper as we integrated. Now we have changed the order of integration, and now you can integrate with this integral with respect to x first, because the variable limit is now with x. So we will take some examples, and after examples you will understand it better. First we take very simple example. So change the order of integration, double integral 0 to 1 x square to root x phi xy dy dx. So we don't have to integrate it actually, because we do not know the function phi xy. I have knowingly taken it because I just want to demonstrate how to change the order. I am not interested to show here how to integrate. So let I is equal to 0 to 1 x square to root x phi xy dy dx. Now as per the method we learned, write down the limits. Limits are x is equal to 0 and x is equal to 1. Then y is equal to x square and y is equal to root x. So now draw the graph, now draw the plot. So this is x-axis, this is y-axis. The region is bounded between x is equal to 0 and x is equal to 1. What is x is equal to 0? X is equal to 0 is y-axis, and take a point 1 comma 0 and draw line parallel to y-axis. So this is the line x is equal to 1. Our region is bounded between these two lines. Now take the benefit of other curves. Y is equal to x square. So you can directly see that y is equal to x square is a parabola. So it will pass through origin. So something like this. But where will this parabola cut this line? You have to find out this. So when x is equal to 1, y is equal to also 1 on the parabola. So this will cut the parabola on this 1 comma 1. This height is 0 comma 1. This height of y-axis is 1. So this is the parabola. Now y is equal to next is y is equal to root x. What is this? Y is equal to root x is actually y square is equal to x. This is again a parabola, and draw this parabola also. Again when x is equal to 1, this line, then y will also 1. So the parabola will intersect at the same point. This is the parabola. So name these parabola. These y is equal to x, and the upper one, this one is y is equal to x square. Now we have drawn the curve. This is the origin 0 0. Now put the limits of y. So as per the steps we learned, limits, new limits. So limits of y, minimum value of y is 0 here, and maximum value of y is 1. So y is 0 and y is equal to 1. This is our lower and upper limit. Then what are the values of x? So for values of x, draw a strip, and when you start moving in left to right direction, the first curve, this curve will give you the lower limit of x. So x is equal to y square for this curve. So x is equal to y square, and then this curve give you the upper limit. So this curve is y is equal to x square, means x is equal to root y. So x is equal to root y. X is equal to minus root y will lie in the second quadrant. So we are not interested in that, because the bounded region lies in first quadrant. So now we have obtained the new limits. Now once we have obtained the limits, write the interchange order of the integral. Now I is equal to 0 to 1. These are limits for y, and y square to root y, these are limits for x. So phi x y, and now this will be integrated first with respect to x. So dx and dy. We have changed the order of this integral. Again now let us another example. This evaluate the integral 1 to e square log y to 2 dx dy. The integral is actually easy, but I am interested to show you how to change after the order of how to integrate after the change of order. So let us name this integral I is equal to 1 to e square and log y to 2 dx dy. Now write down the limits. What are the limits? So here you can see the variable limit. This limit appears in y. So this is limit of x. So outer limits, constant limits, these are for y. So y is equal to 1 and y is equal to e square. Then x is equal to log y and x is equal to 2. These describe the region. So we should write this is x-axis, this is y-axis. What is x is equal to 2? Take a point 1 and 2. So this is 2 comma 0. Draw a vertical line. This is the line x is equal to 2. Now y is equal to 1. So take a point this. This is the line y is equal to 1. Now y is equal to 1, y is equal to e square. So first see this curve. This curve is what? This is actually y is equal to e to the power x. So you have to see that this y is equal to e to the power x intersect y axis and this line x is equal to 2 at which point? So when x is 0 means y axis, on y axis you know x is 0. So when x is 0, y is equal to 1. So this will intersect y axis at this point 0 comma 1, and when x is 2, this line, so y is equal to e to the power 2. So this will intersect somewhere. This point is 2e square, means the height is e square. So we have now two closed regions and we should decide which one we are interested in. So see that y has constant limit and x has variable limit. So if we go from left to right, this is the lower limit and this is the upper limit, means the curve y is equal to e to the power x from the lower limit. You can see here this one log y is equal to e to the power x, x is equal to log y, so y is equal to e to the power x. So this curve from the lower limit and this curve this curve form the upper limit. So where is this curve? This x is equal to 2 meets later, so this form the upper limit. Up lower limit, when you are moving from left to right, so first curve means left curve is lower limit, right curve is upper limit. So this curve y is equal to e to the power x is lower limit, and this line x is equal to is upper limit. So this is the region that we are interested in, and we are not interested in this region. So now we have identified the region. I hope you have understood how we decided to which region we have selected. Now write the new limits, new limits. So earlier this y limits were constant. Now we will limit x. Take x limit size constant. So take minimum to maximum. Minimum value of x is 0. Maximum value of x is 2. So x is equal to 0 and x is equal to 2. These are lower and upper limits. Then you need to find the lower and upper limits for y. So draw a vertical strip and move from top to bottom. So this curve, first curve y is equal to 1 is the lower limit. So y is equal to 1, and the second curve upper curve y is equal to e to the power x is the upper limit. So we have decided the limits. Now just put the integral. What is the integral now? I is equal to 0 to 2, then 1 to e to the power x dy dx, and you can see this is very easy to integrate. This is 0 to first integrate with respect to y, so this will be y 1 to e to the power x is the limit. Put the limit, so 0 to 2 e to the power x minus e, this, and now you can integrate with respect to x. So e to the power x has integral e to the power x and e has integral ex. So this, and the limits are 0 to 2. So at the upper limit we get e square minus 2e, and at the lower limit we get minus 1. So we have finally e square minus 2e minus 1. See the result. We have this limit of y is actually, yes, this was means, so I am correcting it. I am correcting it. So this limit of y, this is limit of y. So y, when you replace y with e to the power x, this is e to the power x. When you replace y with 1, so this is 1. So this we get e to the power minus x 0 to 2. Then now you put the limits. So you have e to the power 2 minus 1 for e to the power x minus 2 minus 0 for x. So finally we obtained e square minus 3. This is our answer. Answer is not my focus. My focus is how did you change the order of integration. Take another example. This is integral 0 to infinity x to infinity 1 by y e to the power minus y dy dx. You can see y has the variable integral in terms of x. So we need to integrate first with respect to y, but e to the power minus y by y is not easy. We will not easily integrate it. This is a tough work, and even I don't know how should we integrate it, but uh, we are going to change the order, and let us see if after changing the order we can integrate or not. So let I is equal to 0 to infinity, then x to infinity 1 by y e to the power minus y dy dx. So write the limits. Limits are x is equal to 0 and x is equal to infinity. Then limits of y are y is equal to x and y is equal to infinity. So we cannot draw the line x is equal to infinity, y is equal to infinity, but you can draw a virtual line to say that this is a line at infinity. Suppose this is x-axis and this is y-axis. Y-axis itself is x is equal to 0, and x is equal to infinity. You can draw a virtual line and say it x is equal to infinity. Then y is equal to x, y is equal to x is this line, y is equal to x, and y is equal to infinity. You can again draw a virtual line of this type, and you can say this is y is equal to infinity. So where does our region lie? We have these regions. One region is this and one region is this. Which region should we select? So I have already discussed that the variable integral decides and it play the major role. So y is equal to infinity, this should be upper line, and y is equal to x should be lower line. So this y is equal to infinity is upper, this y is equal to x is lower. So this is our region. We will not select this region. Now once we have obtained the region, so let us change the limits. New limits limits. So minimum value in this region, minimum value of y is 0 and maximum value of y is infinity. So y is equal to 0 to infinity and x is equal to, for x you need to draw a horizontal strip. So you will move along this. So the region starts with the y-axis, means x is equal to 0. So x starts with 0 and ends with this line y is equal to x. So here x is equal to y. So our new integral means the order changed to 0 to infinity, 0 to y, 1 by y e to the power minus y dx dy. Now we need to integrate x first because it has the variable limit. So for the sake of easiness, let us take this, let us write this as this is equal to 0 to infinity, then 0 to y, 1 by y e to the power minus y dx and dy. Why I have written in this way? First, consider the internal integral. So let us assign this a name. Let let us write on the next page. So let I1 is equal to 0 to y, 1 by y e to the power minus y dx. You can see that 1 by y e to the power minus y has no role in this integral. We just get 1 by y e to the power minus y x 0 to y. So we will get 1 by y e to the power minus y into y, and that is e to the power minus y. So I1 become e to the power minus y only. Now what is our I? So our I is 0 to infinity e to the power minus y. This was the inner integral and dy. So now it is easy to integrate e to the power minus y by minus 1, and the limits are 0 to infinity. So you get 0 minus 1 by minus 1 and is equal to 1. So we have obtained 0 to infinity x to infinity 1 by y e to the power minus y dy dx. This is evaluated as 1, but it was not easy to integrate as it appeared, but we changed the order of integration and then it was very easy to integrate. I have multiple examples to show you the order of integration so that you can learn it easily, but because length of lecture is going longer, to avoid the upload problem on YouTube, I am putting the few questions in the part 2. So just keep the part 2 for 3 4 more questions. Stay connected.